So in this video, I want to introduce you to some basic components of paneling tools. When you take a look at the palettes and the paneling tool, you'll see um, one of the biggest palettes includes some components on generating a grid. Now let's get started with composing a grid. You can create a grid based on giving like points. So when you just say planar grid, so see here, let me just turn on the icon so you can see better. Um, you can just like find it here, planar grid or compose grid. Um, you can generate grids based on points. To just show you how it works, I demonstrate how I feed in the input values. So it asks for a base point. You should give a point either by giving the index values of the base point in curly brackets, or just like simply drop a point and set one point and say 0, 0, 0, for example, and then connect it to the base point. So it doesn't matter. Then it asks for the direction of rows and then directions of the columns of the points. So I would say I want to create a grid in XY plane. So I will just drop in X unit component and Y unit component. You can generate a grid in, for example, XZ. So you can say Z unit. And then instead of Y, give a Z unit to the second direction. And then you're going to have like this kind of direction up there. And then it asks for the distance between rows. So you can just give it a number slider indicating how far you want the vertices be from each other. And also the second distance values along the second direction. Also, you can say how many repetitions you want to have, repetitions of the points you want to have along the first direction and the second direction. So this planar grid is similar to creating a rectangular array of points, but the output will be read through other components that need an input value of a grid. So by this component, paneling to other paneling tool components understand that you already have a grid. Now, let's see how you can create a panel, a surface panel on a grid. When you already developed a grid, whether through polar grid, planar grid, rectangular grid, you can do anything else. You can go to the panel, 2D panel here, and either use Cellulate or use Generate Faces to create a surface and planar faces. So either key in Cellulate or drop in Cellulate from the palette, and then when you connect the grid to it, you'll get the result. Okay, so here it is. Here is the basic panel system that I have now. Something interesting is that you can use list item to work on a certain panel or extract a certain panel. You don't need to isotrim the facade system that you created to extract one panel, because already your surface is divided into some points, some cells, and you can extract any of them. So if you just connect the meshes to a list item and flatten it, you can pick an index an appropriate index for the panel that you want to pick. Also, remember that you can remap this domain to make sure that you can always get the index of all the meshes you have here. Another way to create a planar surface is to generate a face. So you can, again, give it a grid. And here you can say what kind of a shape you want. So you can drop a number slider between 0 to 3, because it says if you pick 0 means you're going to create, just turn this preview off, you're going to create a straight face. If you pick 1, it's bold, 2 iso, and 3 short. Well, since here we have a very plain flat grid, that there is no difference between any of these options. Later, in a different example, when we have a curved grid, then I will show you that how picking different index for the different panel shapes will give us different forms. So here it is. And you can do multiple things. When you have this kind of grid, you can actually morph something into it. Well, you have this grid, and under again, 2D panel, you can pick morph 2D. So you can map or morph a 2D form onto this grid. So it asks, what is the grid? What is the pattern? You can just say, I want to draw a circle. So this is our basic circle. And it doesn't matter where this circle is placed. It can be like in XY plane. And you can morph it onto the surface, which is in XZ plane. And here, it asks that if you want to shift this morphing along a certain direction. So if you say just shift it one by one, means that you're going to have curves in each cell. But if you say shift it to every other panel and pick index of 2, means that it will get started to morph the circle along the X direction, along the Y direction for every other cell that you have here. So this is one way. Another way is that you can call NURBS curve when you already have a face or you already have a cell here. This cell age lets you just create a series of cells. So you can connect cells to vertex. Let me just turn off this. So we have this surface, and if you connect the cells to the vertices, you can have a curve within each cell. And if you connect a Boolean toggle to this periodic and turn it on, you can make the curve closed. So then now you can see you have some curves mapped onto the surface. So this is another way to create like different 2D patterns onto these cells. Okay, so this is all about the basics of creating a grid out of points and turn it into a surface. In the next video, I'm going to show you how to create a curved surface and then work on a curved surface and panelize it, or in other words, tessellate it using kind of matrix.